Yeah, it's your boy Chill here. Welcome back to Chill. We are continuing with our work on the CLI framework. And you guys remember that show they had on MTV called Pimp My Ride? I think it had like Exhibit in it or something. Well, this is like Pimp My Framework. In the last video, we spent some time really adding some bells and whistles to the CLI framework here, and we're going to continue glazing it in this video. Probably finish the glazing. You might notice I changed the name of the rule here. I changed it from need to dependency because I didn't like the way it was. All right, so what are we going to do today to pimp our ride? Well, I've shown you a bunch of ways of customizing the option, but you can also customize the app. And there's one important way of doing that I found need of. Let's say you try to supply an option that isn't in your list. So the validator is going to say, well, I don't know what that is, and that means that it's an error. And usually that's what you want, but sometimes you have other things that interact with the command line that are taking in options that you might not have defined in your list. So if you want to allow any kind of option, it's very simple. You just got to call allow extras on the app object. So let's give the users of our framework the ability to do that. We're going to call this one allow extras. And I mean, this one couldn't be simpler. It's going to take in a pointer to the options container this time. And we're going to get the app from that and call allow extras on it. Set that to true. So the way you would use this is you go into here, you go rule, allow extras, and you just pass it to this. And that's how you would customize the app object itself. Well, you got to give the rule its own, name in here, but there you have it. Now, if we run this one, I'm going to run it with the non-existent option, and it works fine now. Now, if we run with help again, here, the usage part, this name here, and the description is something that you can customize, but we're not giving the developer the option to do that yet. So let us give some customization options in here. So we're going to throw a couple of virtual functions. You could do it a number of ways, but virtual function is probably the easiest. Get name and get desk, and it'll have a default implementation of empty. And because we have virtual functions, just to be safe and complete, we will add this virtual destructor here, even though it won't really be necessary. Now, if the user so desires, they can customize with a little description here. Well, I mean, I guess it would be useful if I actually did something with this. So, in here, when we init, I think that's a good place to do it. We're going to call those virtual functions, and if they're not empty, we're going to set them on the app. Okay, now let's see what we get. Usage, pulling on my yellow leg. Okay, I should probably set this one to be get desk. And there you go. Now you got the description, pulling on my yellow leg, and the usage with the application name in there. Beautiful, beautiful. Okay, now one of the main things that I want to do with this framework is reduce redundancy, reduce the opportunities to change one thing and forget to change the other thing, and then they go out of sync. And we're doing a pretty good job here because now if you add an option to the struct, it automatically is going to get registered into the CLI 11 app. But there's still a little redundancy here. Like, look at here. These names are like, you generally want to keep them the same. So if it says path here, it should say path here. If it says fun time in bed, it should say fun time in bed. So if you change one of these, if you refactor, you could very easily forget to refactor the other one. They get out of sync. And it's not the end of the world, but it is not great. And it's annoying. And also, this here, you have to specify it for every single one. It's redundant, right? So what I want to do is I want to make a macro that will automatically fill this in. And if you give it the name of the structure member, it is going to automatically generate the string for the option from that and put them both in there. So they're always kept in synchronization by default, by design. So the first thing I think we need is a way of generating this given this. So let's go into our utilities, our string utilities, and let's add another little function here. So we're going to call this one camel to kebab, and we'll implement that one in the CPP file. We're not going to do a wide one for now because I'm lazy, but if I ever need it, I'll add the wide version as well. Whenever I'm in a CPP file or not in global namespace, I like to make these shortcuts. So basically the idea here is we're going to work on every single character in the string, and we're going to look at it And if it is uppercase, we're going to transform it to dash plus the lowercase version of it. So let's make our transformer function. So we check if the character is uppercase. If it is, we're going to construct a std string, which is going to be dash plus the lowercase version of that character. So this transformer function takes in characters but outputs strings. And if it is not uppercase, then we just turn that character into a string. So here's our transformer. Now, how do we use ranges with this bad boy? We're going to return. So we take in our camel string, which is a range of characters. Then we're going to transform that range of characters into a range of strings, which are going to have either 1 or 2 characters each. So now we have a range of ranges. So we join that to a single range of characters, and then we convert that to a string. And there you have it. Nice. Now, of course, if this isn't your thing, and many of you probably is not your thing, it's not super easy, but I enjoy it, so I do it. And I like to give you a little bit of exposure to it anyways. But I mean, obviously you could just do this with a loop or whatever if you wanted to. That's perfectly fine as well. What I'm trying to say is I'm built different. All right, so there's your daily dose of ranges. Back to the framework. What are we gonna do in here? So there's std string, option name from element name. It's a little long, but whatever. It's gonna be hidden in a macro anyways. Let's include our string utilities here. And so what we wanna do is we wanna return double dash plus camel to kebab. Guess there's no need for this to be by value. Move it to the top of the file here. Okay, so now we need to make our macro. I think we're ready to make our macro. Now, one of the things you notice about option here is it can take in a variable number of parameters because some of them are defaulted. So in order to enable that through the macro, we're going to have to use a little macro magic. Nothing too crazy. So we'll call this one chill CLI opt. It's going to take in the name. It's going to take in the data type, and then it is going to take in ... And that's everything else. And it's just going to splat that out into the constructor of the option. So we're going to fully qualify this chill CLI option templated on type, give it its name, and then in here, we'll give it to this pointer. We're going to call chill option name from element name. We have to stringify the name. That's very important. Turn that into a string. And then the rest of the stuff, we can splat out those ellipses by going VA-args. And then whatever number of parameters you put in here, that'll just be pooped out into here. No, let's give it a spin here. We'll do chill CLI opt num windows. And that was an int. And now we can get rid of all this stuff. And we just put these things in here. Now, of course, we got to change this into those one. And that's fine. Now, it's the IntelliSense, it doesn't like it. It's going to say like function definition for blah, blah, blah not found. And there's apparently ways you can fix that with special hint files. But yeah, it's not worth it. But yeah, so now if we ever change this, automatically the name of the option on the CLI is going to change. And we don't have to specify this anymore. And it's just nicer. It's a little shorter, and it is more correct by design. Now the question is, does it compile? And the answer is yes. Okay, now we just have to do the same for the flags, and there's a little wrinkle in there as well. You notice that flag's name here, this string isn't directly derived from this, because there's the option of adding a short switch to this. So we need to change it up just a little bit. So let's add one more string function in here called compose flag name. It's going to take in the element name and a shortcut. So in here, let's do auto full name is equal to option name from element name. And now if the shortcut is not empty, then we will append a comma and a single dash plus the shortcut string, which is just going to be a single character, and then we return full name. So if the shortcut is not an empty string, we're going to concatenate that and then return it. So now let's define chill CLI flag, takes in name. Now it doesn't take in type because flags are always Boolean, but it does need to take in the shortcut. And then we'll do again the ... We do our standard class instantiation, and then we're gonna go chill CLI. Well, F me again, I guess. No IntelliSense for me, but compose flag name is I think what we called it. Oh, now it's giving us the IntelliSense, so it's the name plus the shortcut. Remember, name is just an identifier, but shortcut is going to be a string from the beginning, so we don't have to stringify that one. And then VA args, again, splat out the remainder. And how you would use this is you would go, so chill CLI flag, there's the name, and we don't need shit the bed or anything like that, but we do need the short name, and that should just be a string like that, and then the description. And that's looking great. And if you don't want to give it a short, you just got to put an empty string in here. You got to put something because that's just the way that macros work. But it's pretty good and it's a lot shorter. All right, and here's what that looks like. All macroed up to the nines. Beautiful. This is looking very slick. Oh, everything's lined up. Oh, so beautiful. All right, let me show you a little bit more about the advanced benefits of using a library like CLI 11, like how much stuff you get out of the box that you don't have to implement yourself. So one of the cool things you can do, like it accepts a lot of different stuff, not just strings and integers. Like let me specify non-default here, and I'm going to give it a hex string. Let's take a look at the output. Non-default 255. Yep, it just does hex out of the box. Supposedly it even does binary and octal as well. Although I tried binary, I couldn't get it to work, so I don't know what's up there, but that's pretty sweet. Now here's another thing that's kind of crazy. You can give it a vector of stuff. Whatever kind of stuff it normally accepts. So here I'm going to create an option vector of int, supply my magic numbers, and let's see what it can do. So we'll look at our output again, and there you go. You got our 3 numbers into the vector, ready for you. And I mean, there's lots of ones that it supports. So let's try another one. So you can even give it like a std pair and it works. Now there's a problem here, and that is this is a macro. So it thinks this is one macro token and this is another macro token, which is not right. So there's a number of ways we could get around that. We could just not use the macro, or we could go using my pair, create a little alias here, and then use that in here if we wanted to, a little workaround, because I do love my macros. There's a slight inconvenience here if we do like star opts dot pair dot. Yeah, we don't actually get the first and the last if we do it this way. What we really want, and I think we will add that, so we want like const t star operator, there's our drill, and then we'll just return pointer to the data, and this will enable opts.pair pointer to first and opts.pair pointer to second. There you go. How do you like them apples? So let's put that on the command line and let her rip. Oh no, build errors. Okay, what's the problem? I see. You are wide. You are narrow. Be gone. And if we run this, of course, we see our paired 69. Nice. Oh, you can do so much with this. The possibilities are endless. And indeed, I could go like an hour or more just showing you all the things you could do, but I don't want to. But I do want to show you one very useful feature that we have here in CLI 11. So let's say you got any num that you're using throughout your code, and you want to allow the user to specify that through the command line parameters. So what you normally have to do is take it in as like an int and then cast it, and the user would have to know what those numbers mean. Now it's a little streamlined in CLI 11. So first off, you could just put the enum by itself as an option. It just allows you to bind enumerations. So what does that look like? Well, let's take a look on the help. So we put that in help. We say it's dinkum enum, and you get your dinkum enum option. And the way it works is you specify like an integer value and it will work. So let's just test it out. If I run it with dinkum2, it works fine. If I run it with a string like smart, it's not going to work because it couldn't convert. Yeah, you need a number. So it's a little useful that you can use this directly, but it's not super great. Now let's pair that with a little feature. So there's this validator called checked transformer. Let me just replace this empty braces with a std null opt, because that'll make IntelliSense happier. But we'll go CLI, checked transformer, and it takes in a mapping. The mapping is a container of pairs mapping a string to some other value. Could be a string, could be an int, could be an enumeration. And it could be like a vector of pairs. It could even be like a std map. We'll do std map because it's very short. But we can now map. We got a mapping now between the string representation of an enum value and its actual value. And if we supply this to CLI 11, now if we look at our help, it says it's enumeration and value should be within chart 0, fart 1, or smart 2. So you can give chart, fart, smart, or you can give 0, 1, 2, and it works. So if I do this, it will not get mad, and it will have the correct enumeration value for me to access. And that is very good. And if you have you will have the ability to convert your enumerations to strings just built into the programs that you use. And then you can just generate a map from that and use it directly. But I'm going to take it one step further. I am going to make our system here, I'm going to give it the ability to automatically generate these without you having to supply the strings yourself. Now, in order to do this, we're going to need some real magic. How do you use magic? You just got to include magic from VC package, specifically magic-enum. All right, so now we have the magic. How do we use it? Well, let's create a little function here. I'll just put it anywhere. There'll be a little refactoring going on here. But we'll create a function, returns a std function that takes in a CLI option pointer. And we will call this one make-enum map. It's going to need to be templated because we need the enumeration type. So that'll be template type name E for enum. And because it's a template, we'll have to implement it in here. Let's include ranges, and I can put my favorites, my precious in here. All right, so, well, first we build so that VC package will pull in magic-enum. Let's add a boolean in here with the option to ignore case. And we'll set that default to true because I think we want to ignore by default. All right, so magic-enum allows us, we can take an enum, it'll give you all the strings of the enum keys. It uses magic to do this. It uses a bunch of like weird stuff where it basically, I think it just checks every integer in the range and finds all the ones that actually have a corresponding key. And then uses some like type info stuff to get the string representation of that. It's kind of crazy. It has a few limitations, but as long as your enums don't have like, hundreds of keys or thousands of keys, it'll work fine. So let's do it. We'll do using namespace magic-enum. I guess we probably got to include the magic first. We'll include magic-enum.hpp. Enum names. There we go. We have the magic. And we want the enum names of the enumeration E. And there you go. We have the names. This should give us, returns a std array with the names sorted by enum value. So what I could do is I could do auto pairs is equal to view. We're going to zip the names together with the enum values. And then we could just convert that to a std vector. And we could return CLI checked transformer std move pairs. Now, this is great. There might be a small problem. I don't know if it works. I put this in the rule namespace. Should probably put it outside that namespace. Make enum map for dinkum. Moment of truth. Big build. This should probably be an E, shouldn't it? I don't know why I made this return std function. I was thinking something wrong, but I should probably just make this return CLI validator. All right, so we get lots of errors here. And I was prepared for this because I know that there's something about magic-enum that I don't really like, and that is enum names is actually returning an array of string views, which doesn't play nice with a lot of different things. So we need to convert these string views into strings. So we could do like a view, transform, take in a string view, return std string, string view converted to a std string. So we transform these and then we zip that transformation up with the values. I kind of thought that would work, but maybe that's not the problem. So we could, since it wants pairs, and maybe it doesn't think that this thing that we made with zip is a pair, which is not great, but we can, what if we just turn this into a map? Map is very pair-like. Maybe it'll like a map better. It does enjoy a map. All right, the map enjoyer has logged on. And now, here's what it looks like when you want to use it. You just say make map-enum for this bad boy here. And when you now do dinkum smart, is happy. And when you do help, there's all our mappings automatically generated from this using magic-enum. You don't have to do anything. Now, I don't think it is case insensitive right now. Yeah, so it didn't find smart. So we can fix that with a simple, so if ignore case, we just put in an ignore case option in here. Otherwise, we're given the vanilla checked transformer. And now if we run it, works fine. No problem. So you can make it ignore case, and that's the default behavior. Nice, very good. Now there's one last thing I just want to do here. This transformation that you do with ranges, I do it, it's fairly often that you have to do like a conversion from one type to another. And what I want to do here is I'm going to add a new folder, CRN, Chili Ranges. So let's start building. We're going to build up our own little toolbox of range stuff that will be useful in multiple places. So here in our ranges.h header here, we can just add a little template function here, cast. And it just returns returns a view, which is casting to the type T. And then CLI, let's replace ranges with core source CRN ranges. And then we can replace this ugly thing with CRN cast to std string. And there you go. That's much nicer. And that here is some sexy range stuff for you. Take a range of names, an array, cast them, cast each element in that array, then zip it up with an array of values, turn that into a map, easy peasy, and there you go. There's your map. You can now make your check transformer. Okay, there's two small things we wrap up, and then we are done. We are done building the framework, and we're done glazing it. So the first one is this warning is annoying. We don't like it. How do we get rid of it? I'm going to make a header wrap CLI11.h. And in here, we're going to include CLI, but we're going to disable that warning first because it is not an issue for us to handle. It does not belong in our output. And then instead of including this, we include wrap CLI11. Look, Ma, no build warnings. Okay, now the second problem is in the usability here. And the problem is your feedback from the command line goes into the log, which is not great. Like for an end user, they're probably not looking at the log when they're supplying options on the command line. So we need a way of doing that. Normally, command line programs run from the console, so you just spit it out to std out, and they see it. Std out or std error. But in our case, we've got a windowed application, so we have to do something a little different. And I'm going to do a very quick and easy and dirty solution here. So what we're going to do is, first we're going to distinguish between two cases. One case is it's just a help. The user asked for help, and you're showing them the help. That's not really an error. So if the code that was returned is equal to 0, that means that this is a help diagnostic that we got. So what we're going to do is we're going to message box A, null pointer for the window. Going to get diagnostics to a C string for the body, and the title is going to be command line help. And we'll add a little customization here. We're going to use icon information. We're going to make it modal, and we're going to set it to the foreground. Now, otherwise, this was an error because they supplied a malformed command line. So in that case, we're going to do command line parse error, and we're going to do icon error instead of icon information. And there you go. And I mean, this is not great. Well, let's see what it looks like. So let's just run it with help here. And we see here, we get command line help, pulling and pulling on my yellow leg. And here you got all your help in the window. It's not too bad, really. But you can see how this could be a problem if you've got a lot of options. You're going to run out of room. And in that case, you know, you'd probably have to actually make a custom window to show your feedback from the command line, your help. Or you could just spawn a console window and then put it in there like normal, which is probably the best solution, to be honest. Now, if you give a bad option, like let's say this is now a non-number, and we run it, you're going to get command line parse error. Could not convert pair 69 bruh nice. Run with help for more information. So that's pretty good. That's better than just putting it in the error. You could also log it as an error if you wanted, but I think this suffices. All right, and there you have it. There is our CLI framework all built up. We laid the foundation, we built a solid structure, and then we glazed it. We pimped our ride. And now, here's the part where when I was doing the preliminary work on this, I entered a state of, I guess what you could only call despair. I was despairing because there's a huge problem with this thing. And I was like, oh my God, this is great. It's amazing. It's beautiful. It's also completely unusable. I thought I'd have to scrap all the work and just like kind of rewind time for the chill framework because it's just a non-starter. You know, you're wondering what could be such big issue. And that is the cliffhanger for the next episode, the final episode in the CLI framework arc, where I'm going to show you why the current situation is terrible, and we're going to do some C++ compiler magic to make it work. Until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button, helps a lot. And I will see you again with some more chill.